Welcome to our homework support video for Shapes and Designs 1.4. We're going to focus on pages 27 through 33, problems 9 and 19 through 28. Today in class you learned about how to measure angles with protractors and angle rulers, and in tonight's homework you're going to reference some of those skills. In the first question I'm asked to think about benchmark angles, multiples of 30 or 45, and which benchmark angles are closest to the rotation angles that I'm given. So I'm going to go ahead and make a diagram here where I'm showing the different benchmark angles. And you'll notice that I have the red benchmark angles here are 30s. And I'm going to put these on the bigger diagram here. So 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360 if I want a full rotation. So that's, again, these are the 30-degree benchmarks, just like what I have on this diagram here. But then I've added in on top of it the 45-degree benchmarks just so I can see them a little bit more clearly. So again, starting with 0, then I go to 45, then 90, then 135, 180, 225, 270, 315, and I'm there. So again, I think 360 I can highlight again too, but those are the 45-degree benchmarks. And so if I look at these kind of all together, that can help me as a tool. This might be something you want to draw on your own paper or look at your graphic organizer from class to have those handy to look at. So now I'm thinking about what's closest to 40 degrees. And so in this case, I'm going to think about how, well, 40 degrees would be probably closest to 45 degrees. So if I kind of sketch a 40-degree angle, that's closest to 45. When I look at B here, I have an angle of 140 degrees. If I sketch that out as a rotation angle, I can see that I'm going to go more than 135, but not quite as much as 150. So I'm going to probably go with 135 degrees as a good estimate. 175 degrees is getting pretty close to 180. And so again, if I sketch this on here, 175 is really close here. It's almost a straight angle, but not quite. I'm going to call this closest to the benchmark of 180. Now I'm looking at 220 degrees. And so a 220 degree angle, I'm going to again start at 0, and I'm going to go down for 220. So I'm going less than 225, but more than 210. Again, I'm talking about this rotation right here. And as I'm looking at this, right, this is closer to 225 degrees as a benchmark angle. For E, I'm looking at 250. And in this case, right, again, I'm starting at 0. I'm going around and I can see 240 and 270. And so this one might be a little bit trickier to think about for me, but I'm going to think about how this would go 240, 250, 260, 270. So this is probably closest to 240 rather than 270. And lastly, 310 degrees. So if I look at 310, I'm starting at 0, I'm rotating all the way around, and again, if I'm between 300 and 315, I should be able to think about how 310 is closer to 315. So again, I'm talking about this whole rotation right here, and I'm going to call that closest to 315 degrees. So again, that's a little bit about benchmark angles. It's really helpful to have some type of sketch or refer to your graphic organizer as you're working through that problem. For problems 19 through 28, we're going to find some angle measures, and we're going to use this diagram of a protractor. And we're also given some vocabulary. We're told that angle JVK and KVL are called adjacent angles, and that's because they have a common vertex and a common side. So again, that's just a vocabulary term to be aware of. If I see two angles that have a common vertex and a common side, I can call those angles adjacent. So that's vocabulary we'll be adding to our toolkit. So now we're going to actually measure some angles. And so one thing you might want to do before you even start is think about how this protractor is divided up. So for example, I see 0, I see 90, I see 180, and I might be wondering what the value of each of those little check marks is on the side here, what the scale is. And so if I count, for example, the number of marks, so I see 1, 2, 3, 4, 5, 6, 7, 8, 9, I see 9 marks. And so if I take 90 and divide by 9, I get 10. And that tells me that each of these is worth 10 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, 90, right, which lines up with what I was expecting. 100, 110, 120, 130, 140, 150, 160, 170, 180, which again matches up with what I was hoping for. So now this kind of can help me think about what's reasonable as I'm working through this problem. So the first angle that we're going to go ahead and measure is angle JVK. And again, in case you forgot, this little m here just means measure. It's asking me to find the measure of a certain angle. And that little sign there is just the sign for angle. And now I'm going to look for JVK. So starting at J, going to V, and then going to K right here. I'm looking for the measure of this rotation. So this first side lines up with 0. This is my initial side. And then my terminal side lines up with 60 degrees. So I'm going to go ahead and call this a 60-degree angle. The next one I'm going to look at, I have the same terminal, or I'm sorry, I have the same initial side because I'm doing angle JVL, but my terminal side has moved over here to L, right? And so this is my new rotation. And I notice that this is larger than a 90-degree angle. So I'm expecting something that's bigger than 90 degrees. And so again, if I look at where my angle is lining up, it's lining up with 110 degrees. So I'm going to call that the measure of angle JVL. And next I have angle JVM. So again, I'm going to go ahead and erase where I was ending before. I'm now at JVM. And so if I look at this here, I can again see that my angle is larger than 90 degrees. It's also getting a lot closer to 180 degrees. And so I'm looking at where this is lining up on the protractor, and I see 150 degrees. So now I'm going to go ahead and look for a different set of angles that start with K, and that's going to change things up a little bit. So my initial is no longer at 0. So now I'm starting at KVL. So now my new initial side is here at K, and my terminal side is here at L. So it's important for me to recognize what's changing here. So I might at first look at this and think maybe it's 110 degrees. However, I'm not starting at 0 anymore. I'm starting at 60. So now I'm going to have to take 110 and subtract 60 to find out the size of the actual rotation. And in this case, that would be 50 degrees. Next, I'm going to look at angle KVM. So I'm going to go ahead and erase my line here. I'm drawing a line for M. And as I look at this, hopefully you're noticing this too, it looks kind of close to a right angle. And again, I've got to pay attention to the fact that I'm not starting at 0, I'm starting at 60, and now I'm going up to 150. So to find the space I've actually gone, I'm going to do 150 minus 60, and I get 90 degrees. So that angle I'm expecting is 90 degrees. The next one I have is angle LVM. So I'm going to go ahead and change where my initial is starting again. And so LVM, I'm going to start at L right here, go to V, and then go to M. So I'm talking about this little angle right here. I'm noticing it looks kind of like an acute angle that's smaller than 90 degrees. I could even kind of sketch in for myself of approximately a right angle and think, I wonder if this looks like it's about a half or a third. I might be able to think about it some different ways. And so now what I'm going to do is, again, look at where I started and where I ended. And so in this case, I'm going to take 150 and subtract 110 degrees, which will get me to 40 degrees. So I'm going to go ahead and note that this angle is approximately 40 degrees. And now the last part here is talking about complements and supplements. And so I'm hoping you remember that complementary angles have a really special relationship. They add up to 90 degrees. And so basically, if I know I'm looking for the complement, I want to find what other angle I'm adding to the given angle to make that angle sum be 90 degrees. And it's going to form some type of right angle. And then I'm also going to see the term supplementary relationship or supplement. And supplementary angles are two angles that add up to 180 degrees. So again, if I'm given one angle, I should be able to find its supplement, knowing that they both add up to 180 degrees. So keeping that in mind, I'm first being asked to find the complement of a particular angle here. I'm going to go ahead and erase a little bit so I can see these better. And so looking at when I have the complement of angle JVK. So I'm going to take a look here for a second at JVK, which I actually measured earlier. And so I'm going to think 60 plus what would give me 90 degrees. And so in this case, the most reasonable answer would be 30 degrees, right? Because that's what I'd have to add to 60 to get to 90. Then the supplement of angle JVK, and again, JVK is the angle we were just talking about. So I'm going to think 60 plus what would give me 180 degrees, because now I'm talking about supplementary angles. And so here, hopefully you can think this through in your head. 60 plus 120 degrees would get me to 180. Now I'm being asked about the complement of angle MVL. And so MVL is kind of one that I had also measured earlier. So MVL is the same as LVM. That's that 40 degree angle. So I'm going to think 40, so I'll do this in red, 40 plus what would give me 90. And again, that helps me to kind of see that 40 plus 50 degrees would make the most sense. And again, if you look at this here, I could think about I'd have to add 50 more degrees to make this in the shape of a right angle. I can see that these are complementary angles. And then the last question on our homework for tonight is the supplement of angle JVL. So again, JVL is up here as 110 degrees. So I'm going to think 110 plus what would make 180 degrees. Again, working through it this way, I should be able to come up with 70 degrees. So again, I hope you can take a moment and check off all your answers, make sure they're reasonable, think about areas where you may have more questions or may feel like you need more support. And then tomorrow, come to class ready to start thinking about how we are going to apply all that we've been learning about angles to start sketching triangles and other shapes that have specific criteria, such as a certain angle size in a triangle. We'll see you tomorrow.